Please make me host. Okay. So hello, good evening. Welcome to a second lecture of carbohydrates compounds. Carbohydrates compounds. So in the previous class, we have studied about carbon, what are carbons, and its introduction part. Now today we are going to start with homologous series. Now, what do we mean by homologous series? We know that homo means same. Homo means same. So in this series, what is happening? That all the series, they are going to be in same functional group as well as same chemical properties. The compounds, all the compounds are going to have same functional group and same chemical properties. And all the members, all the successive members, like the first member, second member, third member, all the members are going to have a difference of CH2. There will always be a difference between all the compounds. Like if there's the first member, second member, third member. So between the two members, the difference will always be CH2. Okay. So what is a homologous series? Homologous series refers to a series of compounds with the same functional group and similar chemical properties. Clear? Similar chemical properties. And the difference between the two is going to be CH2. Okay. Now, how to see that, how to calculate the difference between all the three? So we have a formula for the alkane, alkene, and alkyne. So in a homologous series, we have three, that is alkane, alkene, as well as alkyne. Okay. So these are the formulas for the respective ones. So here we can see alkane, we can see alkene, and the alkyne. Yes. So we need to just follow this formula so that we can calculate the respective number. So here N means number of carbon atoms. N is going to be number of carbon atoms. If I need to calculate for alkanes, if I want to calculate for alkanes, I just simply need to use this formula so that I'll get all the names of the members. Okay. Just let's go ahead. So see. So here N was the number of carbons. Yes. The formula was what? CnH2n plus 2. So right now I'm taking one carbon atom. So for one carbon atom, C into 1 into H, 2 into 1 plus 2. So C is 1, C ones are, obviously it will be the same, into 2 ones are 2 plus 2. So it makes CH4. And CH4 is for methane. Okay. For methane, it's CH4. If I need to calculate for ethane, first is always methane, ethane, propane. You know this series? Everybody knows. Like, if we have 1, that means methane. 2, ethane. 3, propane. 4, butane. 5, pentane. So on. We'll go so. Okay. So if I need to calculate, so how we are going to calculate for the remaining one? Same. We'll apply the formula. We are going to just apply the formula. The formula will be same. that is CnH2n plus 2. Now I want to calculate for ethane or propane. So propane will be, means 3 carbon atoms. Propane is having 3 carbon atoms. So C3H3 into 2 plus 2. So I'm going to calculate it. So C3, 3 2s are 6 plus 2. So C3H8. So this is the formula for propane. If I want for butane, same, the number will be changed here. The number will be C4, 4 into 2 plus 2. So C4H, 4 2s are 8, 10, C4H, 10. So on. So like this, we can keep on calculating everything. So see, there is always a difference between the two, that is of CH to 8. If I'll subtract 1 carbon from here, C4, I'm having C4H10. I need to minus 1. If I'm going to subtract this, I'm going to get this value only. If I'm going to subtract this, so the difference will be of CH2. So in between all the members, the difference will be of CH2. Clear? Understood?
Yes, ma'am.
Very good. So now moving forward. Now I have the second formula, and the second formula is for alkene. The second formula is for alkene. So for alkene, what is the formula? We'll see here. That is CnH2n. CnH2n. Sorry. It's CnH2n. CnH2n. For alkene, we start with C2. Okay, we take 2 carbon atoms. C2H, 2 into 2. So C2H4. Okay, the next will be C3. C into 3, H into 3 into 2. So H2N. H2N. So C3, 2 3 is a 6. C3, H6. See, again the difference is of CH2. Likewise, for alkyne also, we'll do like that only. For alkyne also, we are going to do the same. So what will be the formula for alkyne? CnH2n minus 2. CnH2n minus 2. Yes, so we'll apply that. CnH2n minus 2. Yes. If I'm taking 2 here, so H2 into 2 minus 2. So what I'm going to get? C2H, 2 to the 4 minus 2, C2H.
H2.
If I'm going to take C3, number of electrons as 3, so number of carbon atoms. So into 3 minus 2. So C3
H4.
H4. So again, the difference is of CH2. So in all the homologous series, all the successive numbers are going to have the difference of CH2 in alkene as well as alkyne. Clear?
What is alkyne, alkenes, and alkynes?
Yes.
What are these alkenes, and
These are all the homologous series. These all are having, they all are having same functional groups and same chemical properties. Okay. Means all the existing homologous series are going to have same functional groups and all are going to have the same chemical properties within them. Now, move to the next. When I'm talking about alkanes have only single bond between them. Single bond, single bond. Alkanes have single bond between them. That is C. Single bond. But when I'm talking about alkenes and alkynes, they have double bond and triple bond between them. Alkenes, they have, for alkenes, we have carbon, single bond carbon. But in alkenes, we have carbon, double bond carbon. And for alkynes, we have carbon, triple bond carbon between them. Okay. You can note this down. As we study alkanes, CnH2n plus 2. So one carbon, methane, CH4. When the carbon of atoms is 2, ethane, C2H6. See, so each and every member, the difference between is of CH2 in alkenes as well as alkynes. Ethene, propene. As I said, in alkenes and alkynes, we start from 2 carbons. Only for alkane, we have 1 carbon. Now coming to our next topic, that is allotropes of carbons. Allotropes of carbons. Now see, when I'm talking about carbon, this chapter is completely about carbon. So carbon is an element which exists in 2 natural conditions, or we can say in 2 states. It might be in free state or it can be in the form of a combined state. Carbon can be seen in free nature as well as in combined nature. Then we are talking about allotropes. So what do we mean by allotropes? So allotropes means the elements which are different, which have different physical forms. Okay, these are the elements which have different physical forms in them. That is called as allotropes. Allotropes are the different physical forms in which an element exists. So we can see allotropes of phosphorus, we can see allotropes of carbon. So right now I'm talking about allotropes of carbons. As said, carbon occurs in nature in a free state as well as in combined state. Yes. Now we have 3 allotropes of carbon. We have 3 allotropes of carbon. First is graphite. Second is diamond. And third is Buckminster fullerene. These are the 3 allotropes of the carbon: graphite, diamond, and Buckminster fullerene.
What is the third one?
Buckminster fullerene. We'll study all the 3. Okay. So these are the allotropes of carbon. We can see they look like this. Carbon. So this one is graphite, this one is diamond, and this one is fullerene. Fullerene is like a football. It's actually, it looks like a football only. It's a complete football shape. Then diamond, and there's a graphite. So we need to study about all these 3. Now, what is a graphite, what is a diamond, and what is fullerene? We can call this fullerene, we can also call this Buckminster fullerene, or as well as we can also like carbon 60 or C60. Okay. Why I'm calling it a C60? Because it has 60 carbons in it. Okay. It has a whole of 60 carbons. So we call it as Now I hope till here it's all clear.
Yes,
So,
ma'am.
now, when I'm talking about the allotropes of carbon, we studied that there are three allotropes. One is the diamond, second is graphite, and the third is Buckminster fullerene. So all the three are very important. So these all are like important points which we need to learn. So first we'll start with diamond. First we'll start with diamond. So what is diamond? In diamond, we know diamond is a non-metal. We studied it. So diamond, it is a non-metal. Diamond is very hard. The structure of diamond is very, very hard. So diamond. Next. Now, how is the structure of diamond formed? Now, how is the structure of the diamond formed? In a diamond, everything is made up of carbons. So every carbon atom is bonded with 4 other carbons. Every carbon atom is bonded with other 4 carbon atoms. There's a carbon. 1, 2, 3, like this. So 1, 2, 3, 4. This carbon is attached to other 4 carbons. If I'm talking about this carbon, so it will be 1, 2, 3, 4. So again, 1 carbon is attached to other 4 carbons. So each and every carbon atom is attached to the other carbon atoms. How many carbon atoms will be there? There will be 4 carbon atoms. So 1 carbon is going to attach with 4 carbons. Then out of that, again a carbon is going to be attached with the 4 carbons. Same way. So it's like a circle going on. Clear?
Yes, ma'am.
In a diamond, one carbon is attached to other carbon atoms. Now that together they form a 3-dimensional structure. Together they form a rigid 3-dimensional structure. As I already showed you before, like they join together forming like this. Okay. Now, after diamond, we have graphite. After diamond, we have the next is graphite. The pencils which we use, the nib in with that is also graphite. The pencil. This is graphite, made up of graphite. So in graphite, what happens? Same. The carbons will be attached to the other carbon atoms, but the number will be changed. Simple. Again, a carbon is going to be attached with other carbons, and they all will form a hexagonal structure. Here, they are going to form a hexagonal structure. So how many carbons are going to be bonded together? If they are forming a hexagonal. Here, they are going to bond with 3 carbon atoms. So 1, 2, 3. Like this. Together, they will form a hexagonal structure. 1, 2, 3. Like this. So 1 carbon attached to 3 carbons. 1 carbon attached to 3 carbons. 1 carbon attached to 3 carbons. Like that. So together, all the carbons, they are going to form a hexagonal structure. Okay. Clear?
They're only sharing 3 carbons with each other.
Yes. In graphite, one carbon atom is attached to other 3 carbon atoms, forming an hexagonal array. So they all together, they'll form an hexagonal structure. So these are the 2, diamond and graphite. Now we are left with the only third allotrope, that is Buckminster fullerene. So let's also called as C60. Now, why we are calling it a C60? Because it is completely made up of 60 carbons. It is made up of 60 carbons. And it looks like a, we can say, football-like structure. We have a football like this with patches everywhere. So it gives a complete look of a football. In this, we have 20 rings, or we can say right. It will be confusing. In Buckminster fullerene, how the structure is made, it has 20 rings. It has 20 rings made up of 5 members like this. 1, 2, 3, 4, 5, 6. So 6 atoms together will be 20. Okay, they will be 20. And 5-membered ones will be 12. Like 1, 2, 3, 1, 2, 3, 4, 5. Like this. So 1, 2, 3. Like this. Fine. From 1, 2, 3, 6. So in this we are having 20 6-membered rings and 12 5-membered rings. So they all together make 60 carbons. So that is why it is called as carbon, or we can say C60 structure. And it gives a structure of a football as shown in the diagram above. So there's a structure of Buckminster fullerene in which we have 20 6-membered rings and 12 5-membered rings. Yeah. Now, moving to the next topic, that is hydrocarbon. They're together. Okay. Hydrocarbons. Hydrocarbons, the elements which are made up of hydrogen, plus carbon. The ones made up of hydrogen and carbon are called as hydrocarbons. So hydrocarbon is of 2 types. Hydrocarbons is of 2 types, cyclic and acyclic. Then again, that is divided into further. So acyclic and cyclic. Cyclic. This is an open chain structure. And this is a closed chain structure. It is a closed chain structure. So acyclic or aliphatic, they are again divided into 3. That is alkane, alkene, and alkyne. And we already discussed about it. Alkyne means single bond, double bond, and a triple bond. Yes.
Sure.
Now, the cyclic ones or the carbocyclics is again further divided into 2. That is alicyclic and aromatic. Again, further alicyclic is divided into 3. That is cycloalkane, cycloalkene, and cycloalkyne. And aromatic, we have benzene. But for our standard, we need to study only cycloalkane. Cycloalkyne and cycloalkene are not in our syllabus. But just to know, I mentioned the names. So we are going to study only cycloalkane and benzene. That's it.
What to call cycling? Like Cyclic.
They will be, obviously, they will be in a cyclic structure. So that's where cyclic and acyclic. See, open chain. If I'm going to form a cycle, will I get an open chain? No. Something lost. Okay. Acyclic. So we already discussed about acyclic open chain, so I'm not discussing it now again. We'll start with aromatic and alicyclic. And in alicyclic, we need to study only cycloalkane. Okay. So in aromatic, this is benzene. Steady. So when I'm talking about benzene, it's very, very simple. We just need to memorize a formula that is C6H6. That's it. Nothing else. If we learn this formula, C6H6, benzene is done. So in C6H6 or in benzene, we get a ring structure, which have 6 carbon atoms and 6 hydrogen atoms. So 1, 2, 3, 4, 5, 6. Okay. In benzene, every alternate carbon has a double bond. Every alternate carbon has a double bond. So like this. So alternate, this is not having double bond, this is having double bond. No double bond, we have a bond. No double bond is there. Okay. So every alternate carbon atom is having a double bond in it. Okay. So we have 6 carbons and 6 hydrogens. Okay. So how we are going to make it properly? 1 carbon attached to a carbon. And this carbon attached to this carbon. This carbon attached to this carbon. And every alternate carbon is having a double bond. Now 6 carbons. Now these 6 carbons will have 6 hydrogen. 1, 2, 3, 4, 5, 6. Okay. Clear? So there's a structure of benzene. And benzene, it forms a ring structure. It gives a ring structure. And every alternate carbon has a double bond. Yes. Now coming to the next topic, that is cycloalkane. That is cycloalkane. So whenever we talk about cycloalkane, see, it will form a cyclic structure. So this will start with 3 carbon atoms, because with 1 or 2 carbon atoms, I cannot form a ring structure. I cannot make a ring structure, but with 3 carbons, we can make a ring. So cycloalkanes will always start with cyclo cyclopropane, having 3 carbons. Because with 3 carbons only, we can form a ring-like structure. Other than that, we cannot form a ring. They are also hydrocarbons. Hydrocarbons means made up of carbon and hydrogen. Made up of carbon and hydrogen. And starts with 3 carbons, that is cyclopropane.
C3H8.
Yes,
C3H8.
exactly. So when we are going to see the diagram, it will be 1 carbon, 2 carbon, 3 carbon. Now H, we need to balance H. So 1, 2, 3, 4, 5, 6. C3H6. Yes or no? What is the formula of cyclopropane? We calculated it. Try
C6.
to.
But to
5, 6. Okay. Now, cyclobutane. So in butane, how many will be there? 4. 4
C6.
carbons. 1, 2, 3, 4. 4 carbon atoms. Now these carbons will be balanced.
How much hydrogen are
So how many? It will be 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We need to balance the carbon bonds. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Carbon has 4 in the outermost. Yes, hydrogen. Now same will be for cyclopentane and all. Okay. So today we discussed about homologous series, then allotropes of carbon, and then the last topic was hydrocarbons. So that's all for today. In the next class, we are going to start with functional groups. Hope you understood till here. Okay, we'll continue tomorrow. Till then, bye-bye. Take care. Good night.